Hello everyone, this is ML Naruto. Welcome to my channel. So it's been already 2 months since I make any new video regarding any topic. So I came today with some exciting topic, that is weighted mean. So what do you mean by weighted mean? I'm going to explain this entire concept right now. So first of all, let's have a look at the definition first. So what is meant by weighted mean? Weighted mean is nothing but the sum of mean of each group and multiplied by number of scores in that respective group. So what do you mean by this number of scores in that respective group? This entire thing itself, we can call them as weights. In short, we can call them as weights. Okay. And then we need to divide this entire multiplication, that is sum of mean of each group into number of scores in that respective group, whole divided by, we need to divide that by the total number of scores in all the groups. Yeah, so this is the entire definition and the formula. See what I have just said. Weighted mean is nothing but the sum of mean of each group into, that is multiplied by number of scores in that respective group, whole divided by total number of scores in all the groups. Just don't get confused by just having a look at this formula. I'll explain with the help of a real world example. Then probably you may get a better understanding about this. Okay. So, but before that, just uh, sorry. But before that, just look at this. When do we use this actually? When do we use this? When do we use this kind of weighted mean here? This particular weighted mean is used when the individual group means are based on the number of items. When individual group means are based on number of items that are not identical. That are not identical. This is the important thing here. See, I'll explain you with the help of an example, but before that, just have a look at here. We usually use this particular weighted mean when individual group means are based on number of items that are not identical. So what does that exactly mean here? Let's imagine, see, let's consider, I'm taking an example. Okay. For example, I have some maybe maths. So I have some maths classes or sections. Okay. I have some math sections. So I have one section that is A and another section that is B and another section that is C. Okay. For example, I'm just taking the average. I'm just taking the average marks that are obtained in this particular subject, that is maths, in section A. Okay. So on an average, each and every person actually on an average, they have got some maybe 70. Okay. And in the B section here, on an average, the students have got some 75 marks actually. And on an average, in the C section, these students have got some 80 marks here. See, there are three different kind of groups here. This is the first group, this is the second group, and this is the third group actually. So these are the three different groups, and for each of these groups I have calculated the mean here. This is my mean actually. 70 is the mean of this A section, and 75 is the mean of this B section, and 80 is the mean of this C section. Okay, so now I want to know that what is the mean for the combined group. See, I have mean for A and mean for B and mean for C individually. But what if I want to find this mean for this entire A, B, C? So I want to find this mean for A, B, and C. So how to do that? Actually, what can we do? See, what do we do usually? 70 is the mean of A group plus 75 is the mean of B group and 80 is the mean of C group, right? And whole divided by how many number of groups are there actually? 1, 2, 3, right? So we usually do, we calculate this thing like 5, 14, 8, 3, and we usually get some 75 as the answer, right? So, but what happen is, if it is only, this is the right method only when we have taken this mean on the same kind of sample here. For example, in the A section, I have some students. Let's imagine I have some students of some 30 students I have. Okay, and in the B section, I have some maybe 35 students, and in the C section I have some 25 students only. Okay, I have taken my mean on these 25 students, and then I got this 80 as my average, and I have taken mean on these 35 students, and I have got the average as 75 here, and I have taken mean on these 30 students in A section, and I have finally got my average as 70, right? When the sample is actually different, then we should never usually apply this kind of formula. Why? Because this particular formula is only applicable when the sample is of same. Let's imagine A has 30 students and B also has 30, C also has 30 students. Then we can definitely use this kind of a formula. But here the sample is different. Here the sample is 30 and here it is 35 and here it is 25. So we should never use this. So what do we use? Here comes to our rescue, that is nothing but the weighted mean. Weighted mean. So using this weighted mean, we can usually compute the average for three different individual groups that are having three different individual samples, right? So how to do that actually? For example, how many students are there in this A section? That is 30, right? So 30 into, just take its average, that is 70, right? And then plus, how many students are there in section B? 35. So 35 into how many, what is the average actually in section B? That is 75. And plus, what is the number of students in section C? That is 25. And what is the average in section C? That is 80. Right? And whole divided by number of students. That is, for A, it is 30. And for B, it is 35. And for C, it is 25. If you compute this entire thing, you will get a value of approximate 74.72. So this would be the weighted mean for all these three groups combined, right? So this would be the scenario. So for any given problem, if the sample is of different value, then we can definitely use this particular technique, that is weighted mean, to compute the mean for the all the number of groups combined. So this formula is actually applicable for the three groups, right? But what if there are a lot more groups? Maybe there are some 40 groups or 50 groups or whatever. So You just need to understand the formula in general. That is, we are actually calculating the mean, that is average, right? So weighted mean in the sense weighted average also. So here I'm representing a small w at the suffix of this capital X bar, that is representing weighted mean actually. So this is the in general formula. This is the sigma. Sigma is in the sense we are actually summing up all the different types of groups, right? So we are actually summing up, that is I equal to 1 to capital K. Okay, capital K. And here Ni into Xi bar whole divided by capital N. So this is the actual formula, in general formula for this weighted mean here. X bar, X suffix W bar is equal to sigma I equal to 1 to K, N suffix I into Xi bar divided by capital N. So this is the formula in general. Now I'm going to explain what are all these denotions here. See, first of all, what is this Ni here? Ni is nothing but the number of cases. Number of cases in any individual group. So what does that mean? Earlier I have told you that we have A, B, C classes, right? And in A class there are 30 students, and B class there are 35, and in C class there are 25 students, right? So these students are nothing but the number of cases here, right? So Ni in the sense, those are the cases. Okay. Okay. And the second one is capital N. This is the thing here, N. N is nothing but the total number of cases. Total number of cases in all the groups. In all the groups here. Okay. What does that mean actually? For example, for A, I have some 30. For B, I have some 35. For C, I have 25. And I want to compute this capital N. Then what does that mean? 30 plus 35 plus 25. So this is the capital N value, right? And next, the last one is Xi bar. Xi bar is, what do you mean by this Xi bar? Xi bar is nothing but whenever you find this particular bar or cap, any of these things, bar or cap, upon any kind of a variable, you should really try to figure out that this is a kind of average, or this is a kind of mean. So we are actually calculating the mean of individual groups. Here I donates individual. So we are actually calculating the mean for the individual groups. For example, the mean for this A section is maybe 70. The mean for this B section is maybe 75. And mean for this C section is maybe 80. So these are all the individual means here, right? So whenever I say Xi bar, what does that mean? Individual groups mean. So Xi could be 70, and also Xi could be 75, and also Xi could be 80. So these three are the three different means that are actually belonging to three different individual groups. So this is all about this weighted average. I hope you have all understood the concepts really well. I'll see you in the next video. Jai Hind.